Welcome to the Fluid Power Lab. Today, we are going to learn how to control immense industrial power. We will be operating a hydraulic double-acting cylinder using a 4x3 directional valve to smoothly push, pull, and lock heavy loads. Think of a double-acting cylinder like a mechanical muscle that can both push and pull. In this cylinder, fluid pressure moves the piston in both directions for extension and retraction. To control this muscle, we use a 4x3 valve. The numbers are a code. The first number means it has 4 ports for fluid to enter and exit, and the second number means it has 3 distinct switching positions. By moving the lever, we direct high-pressure oil to one side of the piston while letting oil escape from the other. But here's the secret to this experiment: the center position. A 4x3 valve has 2 open positions for moving, but it also features a closed neutral position in the middle. When you release the lever, it snaps to this center state, blocking all ports. This creates a load-holding system that traps the fluid and maintains the cylinder's exact position without any drift. It safely locks the heavy load right in mid-air. Before we build this on the trainer kit, remember your checklist. Check all hoses for leaks, ensure your pressure relief valve is set correctly for safety, and verify your port connections. Ready to lock some loads in mid-air? Let's step up to the trainer kit and get started.
Hi, in this video I am going to explain the working of double-acting hydraulic cylinder using a 4x3 directional control valve. The main parts of a hydraulic system are hydraulic pump driven by a prime mover, the pressure relief valve, the FRL unit.
The trainer mentioned the FRL unit, but why is it essential? FRL stands for filter, regulator, and lubricator. The hydraulic fluid must be absolutely clean. If dust or metal particles bypass the FRL, they will score the inside of the cylinder and destroy the seals. Always ensure the FRL is maintained before you turn on the pump. Your system's life depends on it.
The manifolds with the pressure gauges, the direction control valve, and the actuators. These training kits are integrated with PLC and IoT applications, enabling them automation-based operation. So when the system is turned on, the hydraulic pump pressurizes the fluid. The pressurized fluid passes through the hose to the manifold, where a pressure gauge indicates the fluid pressure. From the manifold, the fluid enters the directional control valve. This is a 4x3 directional control valve.
Pay attention to this terminology. Why do we call it 4x3? The 4 represents the number of working ports. P for pump, pressure, T for tank, return, and A and B going to the actuator. The 3 refers to the lever positions: forward, neutral, and reverse. Connecting the wrong hose to the wrong port will reverse your machine's logic. In industrial machines, that kind of mistake can cause a fatal accident.
The 4x3 direction control valve has got 4 ports, namely port P, port T, port A, and port B, and 3 positions controlled by a lever. So in the first position, port P and port A are connected, and port T and port B are connected. So when the lever is held in the first position, the fluid enters the port P, and from port P it is directed to port A. From port A, it enters the inlet port of the hydraulic cylinder, causing the piston to move forward. The fluid present on the other side of the piston is forced out from this outlet port, and it comes to port A. From port A, the fluid from the outlet port is forced out, and it arrives at port B. From port B, the fluid flows to port T, and it is directed towards the tank. In the second position, the port P and port T are connected, and port A and port B are blocked depending upon the type of the valve. So when the lever is in the second position, there is no movement of the cylinder. and the system is in safe and unloaded condition.
Let me explain the unloaded condition. In this center position, the pressurized fluid flows from port P directly to port T and back to the tank. Why is this safe? Because the pump doesn't have to push against a blocked path. If the ports were blocked, the pressure would spike, causing the oil to overheat rapidly. Always return the lever to this middle position before turning the system off.
Whereas in the third position, port P and port B are connected and port A and port T are connected. So when the lever is held in the third position, the fluid comes to port P and it is directed towards port B. From port B, the fluid enters the other side of the piston, causing the piston to retract. The fluid present inside the cylinder is forced out of this port, of the inlet port, and it arrives to port A. From port A, it is directed towards port T and it then reaches the tank. So this is how a double acting cylinder works with the help of a 4x3 directional control valve. The pressure relief valve ensures safety of the system by maintaining the set pressure, and the FRL unit maintains a clean and regulated supply of the fluid that is entering the system.
Stop right there. The pressure relief valve, or PRV, is your most critical safety component. What happens if the cylinder gets physically jammed? The pressure will keep building up until it explodes, spraying high-pressure hot oil everywhere. The PRV prevents this by opening automatically and dumping the excess fluid back to the tank. As an electrician or technician, never tamper with the PRV's factory settings. Safety first.
So when the lever is held in the first position, the fluid from port P is directed towards port A, and from port A, it enters the inlet port of the cylinder, causes the piston to move forward. The fluid present inside the cylinder on the other side of the piston is forced out of this outlet port and it reaches port B. From port B, it is directed towards a tank through port T. In the second position, port P and port T are connected. So the fluid is directly diverted towards a tank and there is no movement of the cylinder. In the third position, port P and port B are connected and port T and port A are connected. So when I hold the lever in the third position, fluid from port P reaches port B, and from port B it enters the other side of the cylinder, causing the piston to retract. The fluid present inside in the cylinder is forced out of the inlet port and it comes to port A. From port A, it is directed towards the tank and through the port T. So this is how the working of a 4x3 directional control valve takes place. So this is the first position. So repeat, sir. So this is the first position. This is the center position, and this is the third position.